Welcome to Code and Cappuccino. So this is the part 2 of closures. If you have not seen my first video of closures, please do check the description. In that I have explained how closures work in the execution context. And if you already know what are closures, this video is just perfect for you. In this video, we are going to discuss three parts. First is the module pattern in closures, second is the Memoize function, and third is the once function in JavaScript. So let's get started. There is something called once function in JavaScript. Let us see what that is. I have created a variable initialize here, and we are kind of passing a function inside once. So I have done like a custom implementation of once here, which we will see further in the video. So it is taking a function initialized here. So the first time when I'm calling the function, this function will get executed. But when I'm calling it for the second or third time, it won't get executed. It's simple, right? As the name says, once. The function will only execute once. So I'll just remove the code from here and let us see the implementation of this. So I want to create a function once which is taking a function as another function as an argument. So here is our argument, that is function. Now we will return another function from it. So return function. Okay. Now in the lexical environment of the inner function, let's keep a variable executed false, because we want to know, right, that if the function is executed or not. If it's executed once, we will just simply return undefined. So here we have created a variable executed in the lexical environment of the inner function. Now let's make this executed true, and we have to call the function. Let's say this function could have some arguments, right? So we can just put the arguments with the help of spread operator. I hope you know what is spread operator. So we are just calling the function and we will simply return it from here. Okay, now this will only happen if it's not executed, right? We have to put a condition. If it's not if executed is false, we will do this thing. Else we will simply return undefined from this. Let us save this and I'll refresh my screen. So yeah, it works, right? For the first time, it's printing initialize, and the other two are just not getting implemented. So let us check this inside the devtools of the browser. Let me go to sources here, and inside the sources, I'm inside index.js, and I will put a debugger over here. After putting the debugger, we will just refresh the screen. And yeah, so inside the scope, we can see that it is forming a closure right here. So we know, right, when we return a function, it will still hold the variables which are into the lexical environment, right? So executed, which is in the parent scope of the inner function, it is still present inside it. Like when we are returning this function, it is still carrying this variable. Again, I want to give the same example, that let's say if we have another variable, we are not using it right here, so it won't be there in the closure. I can show you that. Let me run it, remove, save it and refresh it, and let's put the debugger again. So we want to check that I have put another variable here, right? Will this also get stored inside that scope of closure or not? So it should not. Let's see. So yeah, so we just have executed true here, right? Because executed true is being used by the inner function. The other one, the let b equals 90, it will simply be collected by the garbage collector as we are not using it. Perfect. So this is how once function in JavaScript works. We will also see how it works in the execution context. So let's check that. I hope you're not scratching the head till now. We are talking about closures, so how can we miss the execution context? Hit the subscribe button and let's see how it behaves internally. How the once function works inside the execution context. Whenever a JavaScript program starts, an execution context is formed. So on the first line, we can see that there is a function. So in when we are providing memory to it, we can write here once. For functions, like the whole function is stored, I will just store the whole function here. Now on the 12th line, we have a variable initialize. So let me put it here. To the variables we assign undefined. So we will just give undefined to this. Now, yes, so on the 12th line, if we see that once is getting called, right, and once is a function, it means a function is getting called, and whenever a function is getting called, a new execution context is formed. So here again, let's say this is the execution context of once. Let us deeply see the once function now. On the second line, we have a variable executed. It will be given undefined. Then b will be given undefined. Now we are returning a function from it. This function is there, right? So it will be just get stored here, a whole function, and we have to kind of return this function, right? So it will get returned to the global part. Now we are returning it and then assigning it to initialized. So how is the function returned? It will return kind of anonymous, whatever arguments are there, and whatever code is there, like the whole code of from line 4th to from line 4 to 10. 4 to 10 line of all codes will be there inside this. Now this function is assigned to initialize. So let me remove the undefined, and this function will get assigned to this. Perfect. So 12th line is done. Now let's come to 13th line. We are again calling the function initialize. Whenever we call the function, another execution context is formed. So execution context of initialize. Now let us see what is inside that function. Like from line 5 to line, we have to see from line 5 to 9. So on the 5th line, okay, so when this function is returned, it returns with a baggage, right? And in that baggage, only executed will be there. Since we are only using executed variable inside the function, right? We are not using b. So b variable will simply be in the garbage collector. It will get removed and executed will still be there. The value of it is false till now. Okay, so if executed is false, it will go inside. So it will check the executed value from the baggage, and then executed value we will make it true. Okay, now it will just return this execution context, will return the function, like the function which was present in the argument of it, right? It will just return that function. It means this part of it where we are consoling initialized, right? So that will get executed now as it's returning it, right? So initialized will get printed here. Now on the 14th line we are again calling a function. So again you can just imagine this as a new execution context. Again the whole process will happen, but when we come to line 5, if it's like executed is false, then only it will go inside, right? But in our baggage the executed is true, so it will simply come to line 9 and it will return undefined. So the second time our function is not getting called. This is what we want, right? This is what the functionality of one's function. And same thing will happen on line 15. It will the executed will be still true and it will just return undefined. So I hope you understood the once function implementation. So we have implemented the code, we have seen into the browser, we have also seen the execution context process. So let's jump to our second problem, that is the Memoize part. About the next part of closures, that is the Memoize function. So let me first tell you what this function will do. So for example, we have a add function. Okay, and we are in the add we have two parameters, that is a and b. So we are calling the add with the same arguments, like we are just passing 2 3 and 2 3 and calling it again. So what it should do is, in the first time it should actually calculate and give the answer. That is, you can see in console that it's calculating the result and giving it the answer. But as the arguments are same, right? So in the second time, if we are calling it with the same arguments, it should store somewhere the result and actually just give the result. It should not calculate again. So this is the reason we are creating a custom implementation of Memoize function here. So let me quickly remove it and we will understand how to do that. So I have an add function here, right? So onto the add function we have to add a custom implementation of Memoize function. So Memoize function is actually taking add as an argument, right? So it's a function. So here when we create the custom implementation, the argument will be the function we want to memoize. Now it will return another function, and that function can have arguments. Okay, so here we will create a cache like an object here, so that we can store key value pairs, right? For example, let me tell you the thought process behind creating the object first. For example, the first time we are passing the arguments 2 3, so we want kind of like we will store the argument as a key and the result of it, that is 5, as a value, key value pair. So it is already stored, right? Now if it finds the same argument here, it should just return the value. This is the thought process behind creating an object. So now here let's actually, how can we store the arguments, right? That we have to think. So in object the key is only string. This is the restriction, right? So let's just stringify the arguments. So let me create a variable args and json dot stringify, and we can just pass the args here. So now we have like the args, we have stringified it. Now it is a string. Now we will check if cache of args, if this is already there. If it's already there, we will just return the answer, right? Else means we are calling that for the first time, so we have to calculate the whole process. So for that, let's create a result we have to call the function with the arguments. Also, we are calling the function, and this is for the first time, right? First time means it is not there in the cache, so we have to store in the cache as well. So cache of args equals to result, and we will simply return the result. Okay, let me remove this. We have encountered an error here. Let's see, has already been declared. Okay, we can't take this as a same variable, right? So let me just take it as key. So let me change it everywhere, and it should probably work now. Yes. Okay, let's actually console, right? So that we can know if it's the first time or are we getting it from the cache. So if it goes in the else, it is actually like calling the function, so it's calculating the result. And if it goes in if, so we are fetching it from the cache. Perfect. So for the first time, if we do it, it is actually calculating result, and for the second time it's actually fetching from the cache. So it's working perfectly fine. But so where is the closure part in this, right? So let's see it in the sources part. So you see there are two functions bundled together. So the child function lexical scope we can use into the we can use inside this. This is what we have learned from our previous video of closures, right? So let's see. I'm into the sources part in the dev tool and inside the index.js. Let me put a debugger on this cache and also on the return part here. And let's refresh the screen. So yeah, we are able to see the closure, right? Like the inner function is forming the closure with the Memoize function, and what baggage it is taking? It is taking the cache and the function, because cache we are using it inside the inner function, so it is taking that with it. Also the argument of the Memoize function we are using it inside, so it is taking it with that. Again, I'm repeating this part again. If I create another variable, it will not take it here because this variable we are not using inside the child function. Let me remove the debugger and refresh the screen, and now let's put the debugger again. I have saved it, refresh the screen. So it is still the cache and function, right? The b is still not there in the closure scope. So why it's not there? Because we are not using it. Let's say inside here kind of I'm consoling b, so it will be there into the closure scope. Let me refresh it. Let's put the debugger again and refresh, and the closure part. See, now we have all the three variables inside, like b and cache and the function, because we are using it all inside the child function. So yeah, this is how closure is used into the memoization part. We will also see how this code behaves in the execution context, of course. So let's see this. So whenever a JavaScript program starts, an execution context is formed, right? So as per our code, we on the first line we have a function, right? So the function is Memoize function. So as it's a function, it will just store whole code inside it. Then we will move to the next part, that is the 18th line. So it's a variable. So to all the variables we will assign undefined to it. Now 19th line, again we have another variable, that is memoized add. undefined we will attach. And on the 19th line, we are actually calling the Memoize function, right? So whenever we call a function, a new execution context is formed. So after this, let's move to here, a new execution context. So this is the execution context of Memoize function. Now let's go into the Memoize function and see, like from the second line we have to think now. So we have a cache here, like we are creating a variable here, right? So we will give the value undefined, then b undefined. Now we are returning a function from here. So whenever there is a return function, it is just returning it to the outer execution context. And how it returns, it kind of returns like an anonymous function. So we have a function, it will take all the arguments and the whole code of lines will be there. So from line 5 to line 14, all of it will be there inside this. Okay, so it's just returning it and it's assigning to the memoized add, right? So we initially gave undefined to it. Let's just clear that part and we will assign this function to it. Okay, let's move to the next line. So next line we are consoling and we are calling the memoized add function. Whenever we call a function, a new execution context is formed, right? And when we return a function, so like in the previous execution context, we returned a function, right? So whenever a function is returned, it carries a baggage, right, of its lexical scope, of its lexical environment. So in the lexical environment, it will check first the function. Are we using the function inside the child? Yes, we are. So it will carry it. Then it will check cache. Are we using the cache into the child function? Yes. Are we using the b into the child function? Yes. So it will carry both of it with it. So b has 90, cache is empty, and the function, like the whole add function. So please remember that this also has the baggage with it. Now let's move to the memoized add. Like we are calling memoized add, so it will again create a new execution context. So this is the execution context of memoized add. So memoized add is this function. Like we can assume that it's a child function, this part. Okay, so let's see this. Now we are creating a variable in this. So let's write here a key undefined. We are consoling b here. Now now b is not inside this, right? It will go to the function and it will check its baggage. Is it there? Yes, it's there, 90. So it will just console 90. Okay, now if cache of key is there, so again it will go to the function, it will go to its baggage. Cache is empty right now. Okay, so it will not go inside the if, it will go to the else. It will console the calculating result part. Now we are creating another variable. Let me create, that is the result, and we will just give undefined initially. And here we are calling the function, right? Now where is the function? It doesn't has a function in its local scope. It will go to the function and it will go to the baggage of it. Now here we have a function here, right? So it will just call this function with its arguments. So our function was add one, right? So we are just calling the function with 2 3. So the result will be 5. So we will store it into the cache. So here we have stringified the arcs, right? So assume this as a stringified one, and we are storing it here in the cache. Now we are just returning the result, that is returning 5. So from this execution context we are returning out 5. So again we are printing here 5. So first 90 got printed, then calculating result, then 5. Then we will come to the 21st line, that is console.log memoize stat. Again we are calling a new function, same thing will happen, like a new execution context will be formed. A new execution context, it will go to the child function here, then it will create all the variables. The same process will repeat, but this time it will found the cache of key, right? We have this 2 3 part inside the cache. It will go inside the if, and then it will print the 11th line, calculating result, and then we will go to that it will go to the 8th line, that is fetching from cache, and it will just simply return it. Again we will it will print fetching from cache, it will return 5, so we will print 5. So let us once see the output if we are getting the same. So yes, we found the same thing, right? 90 calculating result, 5 fetching result, and 5. So same thing is here. I hope you get how to create a Memoize function, how closures are used in this, and how it works in the execution context. So let's move to the next question. Is module pattern in JavaScript. And let me tell you, this is a really famous interview question. So let's check this. So we have a counter module here, in which we are in module pattern, that it's like we are using immediately invoked function. So we have a function here and we have a variable count. From this function we are returning a set of different functions, like a object we are returning from it, and we are immediately invoking it. Now we don't have access to count variable when we use it outside. So it actually gives the functionality to create private variables or method. So as you can see on the line 2, this will act as our private variable. So we are doing counter module dot increment. It means it will become 1. Again we are incrementing, it will become 2, and we are just getting the count of it. So till now the count is 2. So we are able to access the methods of it, but we are not able to access directly the count part. So this is what module pattern in JavaScript is. So let me show you how closures are helpful in this. Let us go to the source again. I will put a debugger on every count part, and let's refresh the screen. So you see we are forming a closure, and so what are closures? It will retain the lexical variables if we are using it into the child function. So of course we are using count inside, so we are getting count in the closure scope, or that baggage we discussed in the execution context. So yeah, this is it. So this is what the module pattern in JavaScript is. I hope you understood the 3 examples of closures, and let me tell you, we actually use in real life, real applications. So, and plus these are all important interview questions. So make sure to implement it, code it by yourself. Also make sure to see it in the devtools. And if you are explaining this in an interview and you show the whole process in the devtools, the interviewer will surely get impressed. So I hope you understood it. Please subscribe to the channel, like the video. See you in the next video.